So I guess we can start. So the last talk of the day, I guess everyone is tired. So and yet one more distribution on RISC-V. So we're gonna talk about Fedora and RISC-V. David Abdurrahmanov, I'm independent software engineer, so that means that I'm not employed by Red Hat. I'm not employed by Sci-Fi. So and I'm leading the Fedora RISC-V. So for the last years, basically it was a full-time endeavor. So before we go into the talk, let's do a few questions. So do we have people who are running Fedora or used to run Fedora? Can you raise your hands? Nice, very nice. Okay, do you have people who used to run or still run Red Hat Enterprise or CentOS? It's very nice. Do you have people who do not know what's RISC-V? Okay, that sounds good. So we're gonna look into basically three parts. So the first part, again, how we bootstrap a new distribution, brand new architecture. I guess you can kind of go very fast on that because if you watch the Debian talk, or if you haven't, please go and watch the Debian talk. There's very nice and detailed descriptions of what the Debian did, what is the RISC-V, and the whole history. Basically 94+% of that talk directly applies to Fedora and probably other distributions also. So let's start talking about how you build. So Fedora and basically every distribution, it's a natively built, so we don't do a cross-compilation, which probably is what you do when you're using a open embedded or build root. So most software is going to be written for the native design, so no one intended to be cross-compiled. So if you want to do cross-compilation, for new architecture, you need to probably port it. You probably need to have custom environment, scripting to do a cross-compilation. That takes a lot of time. And when there are some pieces of software which try to cross-compile and we're going to attempt to run it itself or some utilities, and you're probably going to need to hack that software to get it cross-compiled for your architecture. And then finally, you're probably not going to have a very strong hardware at the beginning, and you're probably going to use simulation. So at this point, at least for the RISC-V, the QEMU is actually a strong target. You can even run on full 8 cores. That's very nice. So it's very good to build the whole Fedora stack and probably other distributions. So it's a bit chicken and egg problem. So again, Fedora is built on top of a previous version of Fedora, but we don't have that for the RISC-V. So we need to get to that. And the way to do that is basically build a very minimal root file system. It's not going to look like Fedora. It's going to be very hacked, but basically it needs to have a tool chain with minimal bits, some form of a kernel with some features, and it needs to have Fedora packaging tools. And then you can start putting in the sources and trying building their RPMs. So basically the picture looks like that. We do it in stages. So again, you build a cross tool chain, then you take the tarballs and you build some form of a very minimal rootfs, which you can build, which you can boot natively or under emulation. And again, it has the RPM tool, so we can start building in RPMs. So we're going to rebuild it. In reality, when you think stage 1, stage 2, you think it might be independent. It's not exactly the case. Sometimes you need to go back to the previous stage, enable more features. So it's kind of going back and forward sometimes to get all the features done so you can build a large set of RPMs, and then for most RPMs you actually assemble the new rootfs and you keep building on the new one and keep redoing that. So we have done all of that basically 2.5 years ago. We did some of that again when we finally got the final GLP version, so the ABIs were locked. Nothing is going to be changed. So that finally we can build a last distribution. The last step, which was done basically almost a year ago, was moving to a Fedora infrastructure bit. So that is the Kaj infrastructure. So that means I'm talking to the Kaj hub and web. I'm submitting the packages. We have a lot of the QEMU builders, and we have the boards. We are running KajD. So it takes one of the package. It creates a pristine stage root environment exactly for that build. It builds a package, sends it back to the Kaj. Kaj does internal repositories, distro repositories, assembles disk images, and stuff like that. So the first bootstrap, I believe, was done. So Richard started the whole project, and he's sitting right there. That was in 2016, August 10th, I believe, based on the blog post when he said that he has something which runs RPM build, and I think he announced that on Fedora mailing list. And very quickly, me and Stefan, who's sitting right there, joined this effort. So we have been working on it for a very long time. In 2016, I think, yeah, we already had the 5,000 packages. So that's like 1/4 of Fedora at that point. But yeah, let's move forward. So Fedora is, of course, is upstream first policy. So that means if you want to build a RISC-V, all the changes we do, we have to go upstream, and then we have to rebuild the whole thing. So we have to do not only release engineering infrastructure stuff, doing a lot of also porting. So a lot of things happened. The GCC happened, billigene happens. They had to wait for a kernel. glibc was the last part. When that happened, we started going like mad to get it done. So we also had second and the third bootstraps, and the third one was the final one. Once we have done that, we actually move to the Kaji infrastructure. So that's, again, we in the Kaji, that means we're building the package in the same way that the Fedora official is doing. But this alternative architecture, so it's not using the official infrastructure, we're using a separate infrastructure. So that's a very quick overview how we got to this point where we can actually boot something. So let's maybe look at how does it look in real life. It's, one thing is to build something, get the console maybe it looks like a Fedora, like a distro, but what can you do to how does it look in real life? I think so the first time Fedora booted was in Sci-Fi offices in California. I think that was at the end of March in last year. So that's first time Fedora 28. It's not exactly Fedora 28, because what we did was we built, I think, 24 on top 20, then 25, 26, 28. So it's kind of a hybrid something, which kind of is 28 at that point. So that's a board, Sci-Fi Unleashed boards with FPGA, and again, that's a screenshot from the display. Later, I think a month after, we started getting the boards. So the Sci-Fi actually were donating the boards for various projects. So Richard got one. He got also another one from crowdfunding. So we got 2 boards. DJ from Red Hat got another one for glibc, which you also use for Fedora and also using for kernel stuff. So this is probably the most expensive way you can attach SSD to the system. That's probably $5,000 or $6,000 just to attach SSD. The other boards that Richard is running, we're running NBD, and we do not use the SD cards because those are crappy on the board. And then Atis from Western Digital came in and said and wanted to try something, and he had the micro semi board, so that means you can actually get the USBs, you can have the SSDs, you can get the graphical cards. And I started working on the GNOME desktop, I think, when I visited Sci-Fi offices. So it was like 6 months passed since that time. And I think I told Tatis it's not going to work. It's definitely not going to work. And surprisingly, it did work. The only thing that we struggled was to figure out what you needed to enable on the kernel to get a mouse and a keyboard. And that took like a week to figure out. Other than that, it did work. So this is the first picture of Atis actually booting in a Sci-Fi with a micro semi. And that's GNOME desktop, the same stuff that's running on this laptop, basically. And also, Atis did more demos in various conferences. So we have Fedora 29 running a NAS demo. Here's a media server demo. So it's basically not exactly the toy. So you don't need to go to the console. If you have the hardware, you can actually run real stuff on it. So basically, you're not limited to something. So if you have a goal, if you want to do something on the boards, just figure it out and then just try to get it running. It might work out of the box, like it happened with the GNOME stuff. Might not, but then come to a channel, tweet me or whatever, and you can figure out what's actually wrong. Another thing, so Bellard, the same guy who actually I think invented QEMU, he wrote an email, and he has another project called JS Linux. And if you go to the website, you actually can boot Fedora 29 in the command line. You can also boot in X11. And by the way, the GNOME desktop, that's running Wayland. But you also can do X11 in a browser. You don't need to install anything. The performance might be not exactly what you expect, but it actually works. And also we have a tiny EMU emulation. That's also a thing where you can actually boot Fedora in a graphical user interface. Not exactly at the current versions, things a bit changed. We need a bit of adjustment of, for example, the BBL and the kernel itself is now separate. And also you cannot specify init or D for the tiny EMU, but that's at some point supposed to be happening. So let's go in the current state. What I did and what probably is very wrong, especially if you're a Fedora user. And you probably not want to hear what I'm going to tell in the next slides. So our build farm. So again, we have 3 boards, so 3 physical targets, a couple 86, 64 nodes for running Kaji Hub, Kujiras, the databases, various systemd stuff to schedule. We also have some backup solutions which running Ceph and Rustic to ensure that if by accident the server dies, we can recover. And we had to use that just after Christmas. So originally, all our builders, the QEMU stuff was running on the Richard server, private servers. We had only like 8, I believe. Yeah. And then we moved to a GCC compiling farm. So Facebook donated loads of servers, and we have, I believe, 8 of 16 core servers. And based on my assessment, we have about 64, and we can add another 30-something QEMU targets. And the whole infrastructure at this point, all the QEMUs, that's fully managed by libvirt. So not running long QEMU commands or anything like that. And also, everything we build, at least the disk images at this point and the repositories, are now fully mirrored to official Fedora infrastructure. So if this dies, you can take disk images, you can set up a new Kaji, you can import the whole stuff and just kickstart the new one. Yeah, and that's the URLs. And we have 2 streams, so I'm still building 29 and Fedora Rawhide. Rawhide is basically like a rolling release. And we're also discussing potentially doing CentOS 8, which is a bit more complicated, a lot more complicated at this point. Statistics. So I don't exactly like the numbers because numbers are constantly changing. But according to the Kaji, we had 24,000 successful builds and about 3,500 failed ones. The best week in terms of builds, I did 4,500 successful builds per week. But again, I could do more. But what we don't do, and I'm going to be more slides about that, we don't run tests. And I do other stuff. So basically, when we are running only on those 8 machines, I had some hacks to ensure that we have loads of successful builds and you don't attempt something which is not successful and optimize for the speed. And if you do a comparison for Fedora 30, which is a Rawhide, so the first line is directly from our Kaji. The last 2 lines are from the official Kaji infrastructure. So we have more total packages at this point. So Fedora removed some. We still didn't catch up to that point. Total build, if you look at the ARCs and this one, it's actually smaller. But when I looked at a dozen of the packages, apparently 29 and F30, we have packages added which we never built. But there are plenty of them for some reason. And then again, RPMs, I just asked for directly for architecture and how much we have in RPMs, and then also including all the debug info and debug sources in general. So the package is, if you have to think of package as a source RPM, and that source RPM produces artifacts which can be multiple of RPMs. For example, TextLive, that's delivering you like 6,000 of RPMs. Certain root package delivers a bit more than 100 RPMs. And again, some of these packages might be in general exclusive architecture or something, or we might produce some sub-packages or not based on architecture. So we count in exactly like I have like 100%, 95% for that for each architecture is different number. You know, so that's why I don't like exactly the statistics and numbers. We have lots of problems, loads of them. We basically we are running on more than 10-year-old machine, which was donated. I mean, the whole infrastructure is fully donated. There's no big company kind of like pushing their money and, to get it done. And we're running basically everything on one single machine. At some point, we also even run the QEMU instances on our main server, which does everything. Also, our domain ended up in HTTP secure something. Preload list, and once it ends in that, basically says if you go to HTTP site, you automatically redirect to HTTPS, and you cannot, a normal user cannot go to HTTPS because that's self-signed certificate, which we use to log into our Kaj infrastructure. So people complain that we cannot log in and get the disk images from our Kaji. So we're going to change the domain, so that's going to be fedora.risc5.rocks. So this is going to be very simple. And we still have the boards and QEMU failing. If I basically every day I have like 2 to 3 QEMUs failing, that's basically CPU stalls. I don't know why exactly. The boards fail maybe, I don't know, once, so in 2 months, in 3 months, very rarely, but they still happen. And the whole infrastructure requires a lot of time and maintenance, so the more you do that, the less you can actually do on the porting, which is truly interesting part. So what's missing? Okay, so at this point, we do not sign any RPMs. That might be scary for some people. We could do that, but that probably has a big impact on IOs. And again, the server is not exactly handling the current situation. So I'm not doing that, but we could do that. We don't have a body. Basically, body moves RPMs for different tags in the Kaji. So for example, you build a package which lands in one tag, but someone needs to sign it, so you need to move it for different tags before it lands in the final repository. We don't need it. At this stage, we don't need it. It runs in a Punji. Punji is something which assembles the repositories and the disk images and everything else. We just use the basic Kaji stuff. It does exactly the same stuff. And we don't do default Fedora disk images, but we probably could do that. I don't see actually why not. We don't do modularity support. I don't think a lot of people are using it at this point, but if you want to do CentOS, that's probably a requirement. Modularity basically means that you have a base OS, for example, and then if you want to have a different PHP version, you can just select a different stream, and that stream is independent from the distribution lifecycle. We are going to do a similar thing with this ARME7. We don't support a bootloader specification. And it's basically because we're going to end up using U-boot at some point, which doesn't do that. You need to use grep2 for that. And there are patches for grep2, but there's no still missing parts in the kernel for doing EFI. And also, if you need to update the kernel, you can do DNF upgrade, and everything is going to install. But it's not actually going to run it if you reboot it, because at this point we're using a BBL, and the BBL comes with embedded kernel, so you need to power down, copy a new BBL, and reboot the machine. And again, globally we don't run any tests. Again, we have a lot more QEMUs, so it means I can now start to sacrificing them, and I can then start running the tests, and I can do other stuff which I didn't do before because I needed to optimize it for throughput. Custom bits. We don't use Kaji shadow. Basically, at this stage, we're supposed to use a Kaji shadow. What it does, it just follows the official Kaji. If someone puts a build, it automatically goes to our infrastructure. It ran for half an hour, and I killed it because it tagged something from Fedora 12, and I wasn't happy because of that. So I have my own custom stuff, but it probably needs to be rewritten to do a more correct thing. Again, we don't do Git to source package. I do it on the x86 machine because it takes just 2 minutes to do that. It takes 1 hour, 2 hours if I do on the QEMU. That's like expensive thing. Also, my script attempts to figure out if you have all the dependencies so we can build it. We want to have more successful builds, not just some builds which fail in 2 days because we didn't have something. Yeah, and we have so all the source code for Fedora sits in what you call the dist-git, which basically are lots of Git repositories, and they have an overlay. So there are some patches which I'm not yet happy. I'm not in the Fedora, so I'm supposed to go to Fedora. Plus, there are just in general some ports. So I need to work on getting some of that in the Fedora, probably some of that sending to upstream, and some of that never going to land anywhere because the official stuff is going to be different. We do 4 separate disk images. If you don't know what you want, you probably want to go to this developer. That's one big image. Still fits in an SD card. Yeah, it has everything. It's a Kaja builder. It has all the tools for RPMs. It has X11 minimal stuff. If you want to do Flexbox, iFree, awesome. All the Emacs, Vim, NeoVim, debuggers, all the tools I can figure out to debug ELF stuff, hex editors, compilers, working with disk images. It has a lot of stuff. If you get an image, the smaller image, and you do enough make hash, if your silicon is very weak, you might need to wait some time, 10, 15, 20 minutes. If you need to do that a lot of times, you don't want to do that. If you're a developer and you want to use those disk images for your CI or something, and something is missing, but it's not like 200 megabytes or something, you can probably pull it in a developer image and you just get it out of the box. You need it, you want to test it, download the image, you have your packages in it, and that's it. And I also had to change the scheduling because, again, we have problems with IOs, and doing images are a very costly thing. So this is basically where you can get the images. The old one, stage 4, that we did before going to Kaja, is still where you can boot them, and I know that some people are still using it. You can directly grab something for Kaji. Those are untested, so there might be some issues because it's automatic. And for the root file system, you need to use VDA1 because there is one partition. I cannot I have to make one partition. It's required the way it's built. But if you use the new ones, I kind of select and test. So I'm going to boot them a few times. I'm going to enable AC Linux. I'm going to do QEMU, libvirt, basically. I know that they work to some extent. The targets we actually support, so again, it's a QEMU, libvirt, QEMU, TinyEMU, but again, that needs a bit of modifications, and you can also run it on the boards. And again, you saw the pictures from Atish presentations, and some people are running it, but it doesn't run upstream kernel. A year passed, it still doesn't support the hardware. I don't know how many drivers are missing.
Yeah, a few.
Yeah, so I guess a few more months also needed to get that in, hopefully. But I guess that's 2019 material. It's going to happen. And you don't have, for the latest images, we don't have kernel builds for that. So if you're running on the board, come to our AC channel and then ask for that explicitly. Probably Atish has a tree or something that you can pull and run.
A bunch of people have now trees with those 5 or 6 driver patterns. So.
A few maybe annoying things about RISC-V in general. So the same thing that happened with the 64-bit ARM. Make sure that your config scripts are up to date. The last time we modified was just several months ago, basically 6 months ago. RISC-V only does the word size atomics. That means there's a hack basically in the GCC. If you use a -p thread, then there's a lib spec that's going to say as needed, link with atomics, and then you don't gonna have any issues. But majority of the cases is going to be -lp thread, which works on most common architectures, but not on all architectures. Because that -p thread might be, I don't know, some architectures like it's actually p threads, I believe. So yeah, I think there's a bug report, and I think there's the idea to inline those atomic calls, but no one has time to implement that. And I guess there are only 2 people who might do that. It would be Jim and Palmer.
Yeah.
Another thing that we recently found when I debugged a D language, so D front-end finally landed in the GCC, but we had some problems, was dynamic sections has to be read-only. But that's not the case. As far as I know, as far as the Jim comment, that's a direct copy-paste from a MIPS. And does not apply to RISC-V, even if a comment says that it applies.
Yeah, I think you're right.
Yeah, so hopefully you're going to send the patch to glibc.
We'll get rid of it. glibc's unfrozen now, so we can fix things.
Yeah. And another thing is you might think it's /user/lib64. It's not. Even if we are not multilib, Fedora RISC-V is not a multilib. But the way the natural RISC-V works, it's going to work as a multilib. So in reality, what the linker is going to expect is lib64 / an ABI. We have symlinks, so the old way is still working, so it's somewhat compatible. But in general, on RISC-V, it's slightly different situation. And there's loads of plans. So we have a new main server, so it's slightly better hardware. So Palmer finally sent a pull request to kernel. So 5.0 RC2 got my audit support. So that's in the kernel, it's working. The usage space is posted, but not yet merged. I have a second patch. I know that it works, but it's not yet in the kernel. Probably maybe in the next version we could manage to get it done. The DLang works in the one in the GCC, but I still work on upstream the patches. So again, I need to send a lot of changes from our dist-git overlay to either upstream or to Fedora dist-git. We still don't have ADA support in the GCC, so that's probably going to be a next thing to add. And then look into the Haskell compiler and the Free Pascal, enable the tests, enable building from Git source packages, improving the shadow Kaji functionality, dumping BBL and going with OpenSBI and a U-boot, maybe XT Linux. And also, Alistair recently joined the Fedora RISC-V channel, and he asked to do more testing for QEMU. So also looking into building QEMU daily, nightly builds for CentOS and the Fedora on the Intel architectures also in the RISC-V, because there is a TTG backend for RISC-V, so basically you can emulate Intel on RISC-V, I think. And we could maybe do a demo in 3 minutes. Do you see? So this is from the way to use, I suggest use libvirt, because I think it's much more easier than actually running a QEMU. This is command from the wiki. So we're going to copy it. And so I don't have anything running. I don't have any VMs, but I do have the images downloaded. So I'm going to create a VM. So that should be running already. Yes. I probably cannot. Okay, so we connected to the console. For some reason, the latest BBL takes some time before it boots, but it's booting. So let's hope it boots fast.
Try turning off the lights if you want.
I have no idea which one it is. Nope. Oh, that's nice. So another interesting thing, right, it's still booting, what I would suggest to use, serial log file. So again, our QEMUs are dying, usually the CPU stalls, but there are other bugs. I highly suggest enable that, because if something happens and you cannot log into a system, there is a serial log, and you're probably going to find a kernel crash or something, so you can send. So I highly suggest you to run that, and it's still booting. No, I'm not. I'm probably not interested in that.
Well, we made a decision. I know that this is something similar that we made a decision. Basically, we're going to eventually transition to building everything on dedicated hardware. In the meantime, we're going to build things on generally the same way.
Okay. So it is RISC-V.
I use that quite a bit for
Nice.
testing things while getting it working.
Actually, I think there's one bug in the kernel. So MMU SV48, the QEMU doesn't support, the kernel doesn't support that.
Someone said something like
I
that.
did
Yeah.
on the mailing list, but no one replied.
I looked at it, and I think you're right. I don't know what's going on.
Yeah,
It's supposed to come just
it goes from DTB. DTB says it's, and just prints the one. So what we're gonna do, if we're gonna have time. So this is a D language. I'm not a D language user very much, but I still debug the thing. And maybe one thing that you can change is go back to Intel. There's if get the VP, move to something better than a console. Because now we should have at least colors. Yes, that looks nicer. So, GDC, so we can compile it. So that's, in the GCC 9, again, we have a D front end, which almost works. By default, it's not yet enabled in upstream, but you have all the patches and understand what's happening. So we're going to figure out before the GCC 9 is released. So we're going to compile a word count, which basically is WC command in the D language. It's going to take a few seconds, I guess, like 20 seconds or something. Yeah, so that's a new language. Nice. And so what we can do, so again, that seems correct, I guess. And that's also correct. 20 lines, 48 words. Yeah, it works. So that's a D application running on Fedora 30 rawhide on RISC-V, the GCC 9, which I think no one yet has. Also, there was a talk from Debian. Debian said that the GDB doesn't work on the Linux. So let's do the same. This is a GDB. So backtrace. This, I always make a mistake. How many? Yeah, so you can disassemble. You can do the registers. Yes. So what happens with Fedora rawhide, which again is a rolling, you get the latest kernel. The kernel is rebuilt basically a few times a week. In between the RCs, you get the GDB bumps every week, every 2 weeks, the same as the GCC and a few other bits. So it's, I mean, if you want to have a bleeding edge, it's in the Fedora rawhide. If you don't want to wait for release a few months, it's in here. glibc is also bumped every, at least a week, bi-weekly. And it's a kitchen sink. So the developer image is a kitchen sink. And if something is missing and you need it for demos or development because you want to depend on that, again, go to Fedora's 5 channel or something, tell us what's wrong, and you're probably going to put it in. It's basically, again, it's a one big integration for the upstream. And that, I think, yeah. So these are the companies that basically are the most important. So Tranquility does our main infrastructure. Facebook gave us the servers. Open Source Lab in Oregon, I believe, is hosting a hardware. GC Compile Farm is now is managing that hardware. Sci-Fi did the boards and delivered to the developers. And our latest and greatest major new server is also going to be hosted by Academic Computing Club in Mayo University. So hopefully that new server is going to handle the load better. And again, if you have any questions or you're missing something or something is not working, you want to test something, whatever questions you have, RISC-V or not, you can go to Fedora RISC-V. You're going to find people from Sci-Fi. There's a Polymer. There's Jim. There's a DJ from glibc. There's Alistair now. We have Debian guys. We have Parabola, GNU Linux. We have Open Mandriva guys sitting. So we have a lot of guys from all the places, like almost 40 guys. And if you have a question as a RISC-V, you're most likely going to get an answer in that channel. So that's it.